This video is to review geometric sequences in series. And we have 3 examples we're going to take a look at. This first example here is a word problem. It's talking about a man driving a post into the ground, and the first time he drives it 9 feet into the ground, and each additional hit he drives it 2/3 of the distance of the previous hit. And we want to know the total distance the post has been driven into the ground after 6 hits. So what you would want to do here is look on your formula sheet under geometric, and you would see that there's a formula that looks like this. And this is how we would come up with the formula for the sequence here. And so a sub 1 means the first term. So the first time he drives it into the ground, it goes 9 feet. And then r is our ratio. So that's the constant ratio. So each time it goes 2/3 of the distance. And then to the power of n minus 1. So that's the formula of our distance. And the reason, I guess I should have talked about this in the beginning, the reason we know this is geometric is because it's 2/3 of the distance. We're multiplying by 2/3 every single time. So if you're multiplying by the same thing every single time, that's how you know it's geometric and not arithmetic when you were adding or subtracting the same amount every single time. But to solve the problem here, we want to know the total distance that it's been driven into the ground. So from start to finish. So what you could do is you could start off and do this by hand and figure out each time and then add all those numbers up. But again, just like we talked about in arithmetic, is that we have that sigma key on our calculator that will do that for us. Starting off from 1 to 6 hits, we use this formula that we just came up with, and we put that into our calculator, and that will do it for us. So I went over the 4 parts that you should be typing into the calculator under the arithmetic video. So if you want to go ahead and review that, I'm going to go through this pretty quickly this time around. So you hit the book, make sure you find the sigma key, which is under tab 2. You scroll all the way down under mathematical operators, and you find the sigma, and then you type the expression for your sequence, which we had was 9 times, and with geometric you're going to want to put an extra parentheses there for 2 divided by 3. Go outside of your parentheses to the power of n minus 1. Then we separate it with a comma. We tell our calculator what variable we're using. Then we tell it the bottom number, and then we tell it the top number. And then we hit enter. And so it has now added the first, the second, the third, the fourth, the fifth, and the 6th term for us. So we didn't have to do that calculation, and it came up with 665 over 27. So the key here is being able to remember those different parts of adding, of typing that into our calculator. So again, I'll just put that here. It's the expression, then the variable, then the bottom number, and then the top number. And again, this is on the Inspire. If you're using an 84, it is different, so you should talk to your math teacher about that. Going to the next question. So this looks like this should be something that we type into our calculator. But whenever you see this infinity symbol, that's automatically a red flag. We never type infinity into our calculator, ever. So again, this is when you should turn to your formula sheet. You should see a formula that has infinity for you. And the formula is this. So you just need to know how to use all those different parts and what they mean. So a sub 1 is your first term, and r is your constant ratio. So when you're looking at this, make sure that you know that 5, as it's set up in your formula, that's your first term, that's a sub 1. and 2/3, that's your R, that's your constant ratio. So when you're calculating this, you're doing 5 divided by 1 minus 2/3. Okay, and when you type this into your calculator, you want to make sure that you do, just like it puts on the formula sheet, parentheses here, so that when you get the calculation, that it follows the correct order of operations. When you do this, you should get 15. One more example is very similar to this example, except for it doesn't give it to you with the sigma. It says evaluate the sum of the series, but you have to be able to look at the list of numbers and determine the formula. So as I'm looking at this, the first thing I would look at is say, is it arithmetic? So I'm saying, okay, I subtract 3, but then going from -1 to 1/2, I'm not subtracting 3. So it's not a constant difference, it's not arithmetic. So is it geometric? So I would divide the second term by the first term, so -1 over 2, well, that's -1/2. Then I would divide the second term by the first term, so 1/2 over -1, well, that's -1/2. And lastly, I would check, looks like I made a typo here, this is supposed to be -1/4, but -1/4 over 1/2 is also -1/2. So we see that our constant ratio here is -1/2. So you would go to your formula sheet and see that the formula for a geometric series, again, is this. So you put in your first term, which is 2, times your ratio, which is -1/2 to the power of n minus 1. So, but the ... is what tells you that it's an infinite series. So you're trying to do this. So just like we talked about in the last problem, you're never typing infinity into your calculator. So we're using the exact same formula we did in the last problem. The first term over 1 minus r. So 2 over 1 minus -1/2, which is 1 plus 1/2. And this would give us 4/3. If you have more questions on geometric sequences and series, please see your math teacher.